Welcome back to Unit 6, Lesson 2, Pythagorean Theorem. You've probably heard it before, maybe even referenced in a movie. We're going to talk about it today. Students will be able to apply the Pythagorean Theorem to find missing side lengths of right triangles. The sides that form the right angle, they are also called the two shorter sides, are called legs. So when we look at the triangle here, this is a leg and this is a leg because they are the two shorter sides of the triangle with the right angle in between. They are the ones that create the right angle. So on this triangle, the two short sides are 3 units and 4 units. The other side is the hypotenuse, the longest side, and it is across from the right angle. So here is your hypotenuse. A lot of times people will say that the right angle points to the hypotenuse. In our case, this side length is 3, this side length is 4, and this side length is 5. So we've got the legs of the triangle. Those are going to be your two shorter sides, or the sides that form the right angle. And the other side is the hypotenuse, the longest side. As you learned in Unit 6, Lesson 1, if the sum of the areas of the two smaller sides equals the area of the larger side, then the side lengths will create a right triangle. This relationship is called the Pythagorean Theorem. It is specific only to a squared plus b squared equals c squared. Yesterday or the previous lesson, we looked at whether it was greater than or less than, and this one is only for equal to, and it only works for right triangles. So for this one, we would say, does a squared plus b squared equal c squared? A squared and b squared, those are our two short sides. So 3 squared plus 4 squared, does it equal the longest side, c squared? And in this case, we'd have 9 plus 16, which does in fact equal 25. So we would say 25 equals 25. Yep, that checks out. And we would say it's a right triangle. Now, we knew this was a right triangle already because we could see the picture, but this would be how you would algebraically prove it. So here we would have that little question mark, right? Whether or not we were going to get an equal to. Since we did, we know it's a right triangle. If someone told you that something was a right triangle, you could always check using the Pythagorean theorem whether or not it actually is a right triangle. So for the next part, it says, Pythagorean theorem in words: for any right triangle, the sum of the squares of the lengths of the legs, A and B, equals the square of the length of the hypotenuse, C. If that sounds vaguely familiar, it was used in The Wizard of Oz, and it was quoted incorrectly by the scarecrow at the very end of the movie. Algebraically, a squared plus b squared equals c squared. Again, right triangles only. If you think back to the previous lesson, we had a squared plus b squared, and it was specific to right triangles. That's how we knew if something was a right triangle. So on this one, we're going to look at a missing side length. How do we find a missing side length if we know it's a right triangle? So when I look at this diagram, I can see there's a right angle symbol, and I am looking for a missing side. So this is a leg, and this is a leg, and then the hypotenuse is the remaining side that the right angle is pointing to. So I'm going to check to see a squared plus b squared equals c squared. What value of c will make that true? I know I have to use a squared plus b squared equals c squared because the right angle symbol is there. I can use 6 and 8 as a and b. I always put the smallest one first. It would still work if you used 8 squared plus 6 squared because the commutative property says you can change the order. And here at the end, you'll notice I still have c squared. Some people will also switch that to x squared. Since x was used on the triangle itself, they both will work. 36 plus 64 equals x squared. Well, what is 36 plus 64? It is 100 equals x squared. So we have one step left. What is the inverse of squaring? X squared is what we see on the paper. So we're going to use the inverse, which is to square root both sides of the equation. And we're going to get 10 equals x. Because it is a length, I'm only going to use 10, not worry about the negative 10. So x equals 10 centimeters, or you can say c equals 10 centimeters. Both would work, c being the longest side. So this is a right triangle, and the missing side length was 10 centimeters. The second one that we have, you will notice that this time it is a leg that is missing. So this side on the far right, the y, and this side labeled 16 inches, they're the two sides that make up the right angle. They're touching the right angle. The side that is the hypotenuse is the 34 because it is across from the right angle. We're going to use a squared plus b squared equals c squared to find this missing side. One of the short sides is the y, so we can say y squared plus. The other short side is 16 squared equals. Now this time we have the hypotenuse, it's 34. So equals 34 squared. We have to make sure that the one that's missing is a leg, so the one that's missing here is either a or b. So y squared plus, now 16 squared is 256 equals, and 34 squared is 1,156. You could do 34 times 34 to get that number. So over here, I've got something with a variable plus 256. So I'm going to subtract 256 from both sides. I'm going to have y squared equals, the result of that is 900. Now again, I'm at a point where my variable is squared and I need to do the inverse. The paper says squared, so I'm going to use square root on both sides. Y equals 30, because 30 times 30 would be 900. The missing side is either y equals 30 inches, or you can say c equals 30 inches. But you'll notice there was a different way of solving it. I still used a squared plus b squared equals c squared on both. This one had a missing hypotenuse, and this one had a missing leg. And the solving was slightly different. So if you're going to go back and you're going to reference one of these, check your paper, check the problem that you're doing, see if you have a missing leg or a missing hypotenuse, and then you'll know which one your work should look like. When we look at the back, we have two more that have things that are missing, and the one that's on the left is a little bit unique. So we're going to do the same. It's a right angle. It's a right triangle. I've got two legs, but this time both of the legs have a variable. And then the hypotenuse is the one thing that we know, the 36. So we're going to say a squared plus b squared equals c squared. And this time I have two variables, which means I'm going to put them in x squared plus x squared equals, and I know that 36 is the c because it's the longest side. The reason it's important to substitute the x's is now that I have them in there, they are the same variable. So 1x squared plus another 1x squared makes 2x squared, and 36 squared is 1296. This is really important. This one's very unique. If you have any homework, any quiz, any test, any study guide where both of the legs are a variable, this is the one to look back at. This is multiplication, 2 times x squared, so I'm going to divide both sides by 2. X squared equals 648. And because it says x squared, I'm going to do the inverse, which is to square root both of them. Now, 648, not a square number. So if you use a calculator, you will notice that it is approximately 25.46 feet. Now, you'll notice I didn't bother going back and saying A and B since there were two of them. I just left it as x. Both of the x's, approximately 25.46 feet. The remaining one over here, I'm going to identify my legs. They are the ones touching the right angle. It's 28 and y, so this one has a missing leg. I also know the hypotenuse on this one, the 33. So a squared plus b squared equals c squared. Because it's a right triangle, I know to use that formula. I'm going to have 28 squared plus y squared equals 33 squared. The missing one is a leg, so this one takes a little bit more of the work than when it was a missing hypotenuse. 28 squared, or 28 times 28, is 784, plus y squared equals, and 33 squared, or 33 times 33, is 1080. I have a number being added to the y squared to the variable, so I'm going to subtract 784 from both sides. Y squared equals 305. And because it's squared on the paper, I'm going to do the inverse, which is to square root. And y is approximately 17.46 meters. Again, 305, not a square number. So you had to use a calculator to estimate or round that answer. All right, now, sometimes you're going to have to draw your own picture. You're flying a kite. You have let out 200 feet of string. The kite's shadow is 135 feet from you, and the sun is directly overhead. How high is the kite? Now, kites don't go straight up. If you've ever flown a kite, they always go off to the side. So let's draw a little picture here of a string with a kite. You've let out 200 feet of string, all right? and the kite's shadow is 135 feet from you. Well, you are here, and the shadow is going to be over here on the ground, 135 feet from you. And the sun is directly overhead. How high is the kite? So the thing we don't know here is the height. So it is a crude drawing because that is not my strength. But because the sun is directly overhead, here's your right angle. That tells me that we've got a leg, and the hypotenuse is the string of the kite that is at a diagonal. So I'm going to start with a squared plus b squared equals c squared. A squared, well, missing side is a leg, so I'll put x there for x squared. The other short side is 135 squared equals, and the hypotenuse is 200 squared. I would have to do 135 squared, which is 18,225. I would have to do 200 squared, which is 40,000. And because that number is being added to x squared, I'm going to subtract it from both sides. And I would have x squared equals 21,775. Now, the paper says x squared. I know the inverse is to square root both sides. X is approximately, when I type this into the calculator and hit the square root key, 147.56 feet. It's not pretty, but it works. And we would estimate to typically the 100th place. So we can say the kite is about, and that gets us our approximately, 147.56 feet above the shadow. And this problem happens all the time with shadows to make a right angle and a Pythagorean theorem question. You will notice at the very bottom, the last thing, when the lengths of the sides of a right triangle are all natural numbers, the lengths are called a Pythagorean triple. That means all of the side lengths are not decimals, not fractions, not negative, not zero. There are counting numbers. So a Pythagorean triple, one example of a Pythagorean triple from the front was the very first one, the 3, 4, 5 triangle. That's a Pythagorean triple. It's also the smallest one where you have all natural numbers. And then the one at the very bottom left was a 6, 8, 10. Those are all natural numbers. And the one on the front to the right of that was 16, 30, 34. So we looked at 3 different Pythagorean triples on these notes.